Hello, Calc. You'll be looking at this one after Tuesday's class, 1-3-17. We're going to be looking at continuity, and continuity is a topic that you always find a few questions on in a math placement test or an AP exam test, so it's important to understand or review that basic concept. And it's not very difficult. It's if the graph of the function doesn't have any breaks or holes in it within a certain interval, the function is continuous at that interval. Simple polynomials, such as a polynomial, it looks like this, like 3x cubed plus 2x squared minus 3x plus 5, that kind of expression. Where these are integers and these are real numbers. Those kind of expressions, polynomials, are continuous everywhere. So if you're given those, it's quite simple. But the ones where there are discontinuities are some trig functions, rational functions, and piecewise. So normally the questions they'll throw at us will come from those groups. So let's review continuity and see what we learn. For a function to be continuous at a point, say x equals c, it had to meet three conditions. First of all, the function evaluated at the point c must exist. Second of all, the limit of the function as x approaches c must exist. And remember, for it to exist, a limit to exist, it'll be from the left and from the right. And then number 1 and number 2 have to be equal. So this limit from the left and the right will have to equal the function at the point c, the point of interest. So those are the three conditions for continuity at a point. So we'll just do an example or two and see how to figure that out. I'm going to pick ones that are troublesome. So let's do piecewise. Those can be troublesome. So here we have this piecewise function. And the question is this continuous at x equals 2? So when it's piecewise, I'm not sure what this one looks like, but it might go like this and then stay connected and bend and go another way. That's continuous. Or it might go like this, stop here, and then jump up here and go like that. Then it's not. So without looking at the graph, we can tell by answering the three questions. Is it continuous at x equals 2? The first question is, does it exist at f of 2? Does that exist? Which of these two will we put 2 into? Well, it's not defined on this one. That's only when x is less than 2. But it is defined, 2 is defined on this piece. So we put in a 2 and get f of 2 is 2 times 2 minus 1, or 3. So we met the first condition. Second condition was, does the limit exist as x approaches c? So to talk about this, we're going to take the limit as x approaches 2 from the left and the right. So this is what's true when x is greater than 2. So this will be, when x is less than 2. So this will be from the right. So when we put in 2 here, we get a 3. And this is when we're coming in from the right, for when x is greater than 2. So we put a 2 in here, we get 2 times 2 minus 1, we also get 3. So the limit from the left and the right were the same. So does the limit exist for that? Right, we already saw up here that it equaled 3 on one side, and we check in from the other side, and it does equal 3 from both sides. So 2 plus 1, and here we would do 2 times 2 minus 1. So we met the second condition. The third condition is the limit. The first number 1 and 2 have to be equal. Well, in the first part we got a 3, and the second part we got a 3, so they are equal. So They do equal each other, so it is continuous. So it must be one of these where the graphs connect. All right, so let's look at another example. How about this one? Is it continuous at x equals 2? See if you can try that one for a minute. Then I'll reveal my answer. Oh, this is the same one. Is that right? I'm sorry. Turn the paper over. Let me get you another one there. Let's try this one. Ready? Here we go. Let me turn the paper over here. Okay, I'll give you this one. I'll let you bring the answer to class tomorrow, so I won't take up all the video time. So you're going to do the same thing I did, and we're going to say f of x equals x plus 1 when x is less than 2. It equals x squared when x equals 2, and it's going to equal 2x minus 1 when x is greater than 2. All right, so I want to know, is it continuous at x? Is it continuous at x equals 2? All right, so I want you to apply the 3 steps and tell me what you think. All right, we'll discuss that when you come in tomorrow. All right, the only other thing I want to say about continuity is there are 4 types of discontinuities, and I think I only really presented one to you in class. I might have mentioned them. This one is called, obviously it stops here. It is a function. It's defined at all points on the no more than 1 point on each vertical line drawn, but there is a jump here, and it's continuous if you can draw the whole function without lifting your pencil. Obviously I can't draw this one like that. It's called a jump discontinuity for obvious reasons. Here's one where there's a hole here, but the point exists off of the beaten path here, and that's called a point discontinuity. I might have mentioned these. And this is the one I don't remember mentioning. Obviously it's not continuous here when there's an asymptote. That's called an essential discontinuity. And I know I mentioned this one before. And there's this kind where there's just a hole. There's no point above it or in any way related to it. And that is called a removable discontinuity. And the reason it's called a removable discontinuity is, say we have a function, this is called a rational function. And because it's a ratio, so we have an expression in a numerator and a denominator, so it's called a rational expression. We can factor the bottom, and notice that this factor repeats in the top or the bottom. So when it does that, they can cancel one another, but what it causes is a hole at this, because if we only had this factor without this one, it would be a 0. If we only had this factor without this one, it would be an asymptote. So it can be a 0 and an asymptote. So what happens is there's a hole at x equals minus 2. So when we cancel that, we get 1 over x plus 3. We should remember how to graph that quickly. It's just the reciprocal function, slash slash, moved over to the left 3. So I drew it down here. And the only thing I have to add is a hole at x equals minus 2. Because that's what would cause this factor to 0 out. So at x equals minus 2, I have to rise or fall until I reach the function, and I put a hole in there. So I can't have this value. It's a hole. And that's called a removable discontinuity. And I guess because we can remove it by canceling like that. But anyway, that's its name. All right, that's all for continuity. You'll be working on problems if you haven't started them already. So, from me to you, over and out.